Okay, a very good evening to Dr. Rahman and my fellow friends. Today, our group as Group 1 from Season 6 will be presenting about the Assemble Ruby A3 with preliminary design. So, by right, I'm going to present about the introduction part. Okay, so the pipeline has become a necessity of one of the most ingestion demand aspect in the industry area in this modern era globalization, as opposed to the previous generation. As a result, if periodic maintenance is not performed, pipes are vulnerable to internal and external corrosion, cracking, manufacturing faults, and other third-party damage. The ecosystem could be harmed if contents spill into pipelines, especially if the pipes are carrying gas or chemicals. Non-destructive testing (NDT) is a testing and analysis technique used by industry to evaluate the properties of a material, component, structure, or system for the characteristic difference of welding defect and discontinuity without causing damage to the original part. Okay, so in this project, our group was planned to design a motorizer and adjustable clamp for NTT inspection of pipework with diameter ranging from 6 to 20 inches in our project. By right, I'm going to pass to my member for the coming part.
Details or completeness of design. For this part, we use as product view from SolidWorks. There are 6 items in this design. Firstly is the clamp. Second is the roller. We use 4 rollers in this design. Next is the shoes and transducer case. Lastly is the screws and nuts to tighten the clamp. Functionality customer. Customers typically evaluate potential solutions based on whether they will help them achieve a particular task or function. The product or service that best addresses their functional need is likely to be the one they purchase or hire. Customers are alternative solutions to improve or create a new design based on their needs. Depending on the customer purchasing criteria, functional demands might be wide. For example, a customer who wants to accurate a motor at the clamp will deal with the best seller who provide high quality of products. With this, the company can develop new design for their product. Next is feasibility of the product. Scheduling is the time management of the project. Team members can estimate the time to complete the task given, and it can be the main key for the project finish on the time. Second is technical, the process of providing the ideas or concept for the project. Decide the best idea concept among the team members and improve the ideas to become better designs. Furthermore, economic. This is to evaluate the effectiveness of the design by using the cost or benefit analysis method. Define the validity, cost, and benefit of the project before the final financial resources are allocated. Lastly is the competitive. Discover whether there is many competitors in the market before we proceed to designing stage.
Assalamualaikum and selamat sejahtera. So now we will proceed to next subtopic, which is engineering analysis. There we will focus on the end evaluation of simple calculation to determine the stress, total information, and factor of safety. So the first one is stress. The contact surface of the manual roller and the mechanical clamp against the pipe with a diameter of 6 inch to 20 inch is used to compute the stress. The pipe is clamped with an 8 kg clamp. So the mass has been set in as 8 kg. The acceleration due to gravity is 9.81 meter per second square, and the force we will find by using the formula m times g, which is the mass times with the acceleration, and we will get 78.48 Newton. The contact area of the clamp and the roller area is equal to length times width, which is the length and the width have been given in this diagram. The length is 0.18 and the width is 0.11, and we will get as 0.0198 meter per second square. And the next one is stress. Stress, by using the formula F over A, we will get 78.48 over 0.0198 which is equal to 3963.64 Pascal. So the next one is total deformation. In this section, we will make assumption which the user will attach the transducer and shoe to the clamp and add force on it. So we decided to use the beam deflection method in order to calculate the maximum deformation of the clamp. So here we provided the diagram to find the total deformation. The first step is we will find the total reaction in the y direction, which is RA plus RB minus 78.48 equal to 0. And this one will act as the equation number 1. The second one is we find the moment inertia at point A, which is the RB times with the distance and 78.48 times with the distance will equal to 0. And this will act as equation number 2. So step 2, we solve the equation for number 2 by plot in the value, and we will get the value for RB, which is 21.7 Newton. Step number 3, we will solve the equation number 1 by substituting the value of RB on the previous step into the equation, and we will get the RA value is equal to 56.51 Newton. Next, we will use the moment inertia equation to find the moment at point J, which is m equal to RAX. And the next one we use the elastic curve equation. So when we use the elastic curve equation, we will get the 1 over 6 times RAX cubed plus C1x plus C2. Step number 4, at point A, the first boundary condition is x equal to 0 and y equal to 0. So by plotting this value, we will get the C2 is equal to 0. Step number 5, at point B, the second boundary condition, x equal L and y equal to 0. By plotting the value of L and 0, we will get the elastic curve equation as 1 over 6 times RAX cubed minus 1 over 6 RAL power of 2x. And step number 6 is the maximum deflection occurs at x equal to L over 2. By plotting the value of x into the equation, we will get the elastic curve equation as the negative 1 over 16 times RAL cubed. So the last step is, since L is equal to 0.25 meter and RA is equal to 56.51 Newton and the aluminium is equal to 69 gigapascal and the moment inertia is 5.717 times 0 exponent negative 6 meter power of 4, we can find the maximum deflection for this structure. So the maximum deflection is equal to 0.00014 millimeter. The next one, we will go to the factor of safety. So in this section, the safety factor is calculated by dividing the ultimate stress by actual stress. Aluminium's ultimate stress is 110 megapascal. Because of the factor of the safety is considerably greater than 1, the clamp should theoretically perform fine under the normal condition. So we use the formula to find the factor of safety, which is the ultimate stress over the actual stress. The ultimate stress has been provided as 110 times 10 power of 6 over 3963.64 Pascal, and we will get the 27,752. That is the factor of safety for the structure. That's all from me. Thank you.
Hi, first topic that I will present is DFMA. This is a drawing of final design before improvisation. Based on the figure, we have recognized some problems and the replacement of components that can improve our final design. First, when we attach the shoe with mechanical clamp by using screw, it will leave some space between them and it may cause vibration during the process. Next, the usage of strap looked useless because its function was same as the mechanical clamp. And lastly, standard roller cannot attach the clamp because the surface of clamp is curved and round, so we need to modify it. As you can see, this is our final design after improvisation. First, we create a hole to the mechanical clamp to insert the shoe and transducer. In this design, we remove straps and replace it by using long bolt that can connect the clamp. Instead of using 4 short bolts and 8 nuts, we decide to use only 2 long bolts and 4 nuts. Lastly, we also fabricate the ruler so it can insert through the thickness of the clamp and use small bolt and nut to attach it. Comparison of final design before and after the FMA. As you can see, for assembly time, the improvement after the FMA is 50%. For total number of parts, 35%. For the total number of ads is 30%. Weight 20%, and lastly for cost, improve 50%. Next is FMEA. First failure mode is sensor detection problem. This table shows before and after redesign. Our objective is to increase the accuracy of final result inspection. Second failure mode is the limit range of clamp diameter. Our objective is to create the clamp that can use for variable diameter of pipe, especially for range 6 inch to 20 inch. And third failure mode is connection of roller and pipe surface problem. Our objective is to minimize the damage to the pipe surface. Human factor, ergonomics and words. We divide it into 3 parts. First is physical ergonomics. It more concerns with the interaction between the individual and the systems. Next is cognitive element. It's study of mental process, awareness and information process. And lastly, organizational aspect. Uh, this is study about socio-technical system, organizational structure, and strategy. That's all from me. Thank you.
Product technical specification. For screw, mechanical clamp, bolt and nut, we purchase it at store, and roller we fabricate it. After discussing the feasibility of fabricating and purchasing all pieces, this conclusion being made. Components such as screw, mechanical clamp, bolt and nut are difficult to manufacture. It is very convenient for us to purchase it on the market based on specification that we require. Besides, there are a lot of stores that provide component and parts. As a conclusion, we can easily obtain parts that fit for our design. In addition, due to the shape design, we are going to fabricate roller only. This is because we designed this part by ourselves and it is difficult to find a part with identical dimension. It also needs to be attached to a mechanical clamp without any problem. Development cost of ideal pipe clamp. Screw for quantity 2 are 2 ringgit each. Mechanical clamp are 20 ringgit. Bolt and nut. Long bolt in quantity 2, 4 nut 4, 1 small bolt and 1 small nut in quantity 4. Each part 70 cent. Roller quantity 4, 50 ringgit each, and the total cost sum up about 94 and 40 cent. By calculating development cost, we determine that the minimum cost required to assemble a product. Therefore, we will be able to estimate exactly what we need to buy for the fabrication process later. The component quantities are determined by reference to the concept drawing. The pricing of this component has been researched to ensure that we can obtain them of good quality at a fair price. As a result, we assure that we will be able to complete product fabrication within the allocated budget, which is 350 ringgit. Type material for each component. For the mechanical clamp, we choose galvanized stainless steel. The use of stainless steel is very convenient, with a strong clamp function, outstanding sealing. In addition, stainless steel clamp also has strong corrosion resistant and wear resistant, long service life. For us to save a lot of manpower and to a certain extent also save a lot of cost. Stainless steel is ideal when used in any setting where they could be exposed to moisture corrosion, oxidant, or similarly harsh environmental conditions. We decide rubber as the roller. Rubber roller take advantage of the desirable properties of elastomers such as impact strength, shock absorption, abrasion resistance, high coefficient of friction, and controllable degree of hardness. Rubber is a distinct modern advantage as it is more durable than metal, which is susceptible to cracking, rusting, and other forms of damage over time. Not only is rubber more resilient, but it also handles heavy weight better as it has neutral give and flexible, which allow for even weight distribution throughout the roller instead of concentrate pressure at the point of contact. Screw and bolt and nut made from stainless steel are chemical and corrosion resistant. They have an appealing surface finish. They cannot be hardened like carbon steel. For the project plan, this project took around 15 weeks to be complete and will continue next semester. It started with product planning. We identified the problem for 2 weeks and designed the product specification from week 2 to week 5. After that, we determined the function study and function diagram of the product in week 4 to week 7. On week 6, we started to list out all the design by using the morphological chart. Each member has designed the concept sketching and one of the total of 5 concept sketching has been chosen after calculating the concept scoring. The analysis of DFMA, FMEA and human factor was conducted from week 10 to week 12. Cost to construct this product has been discussed and determined from week 10 until week 13. The drawing design of the product started on week 11 by using the SolidWorks software.
Okay, for the conclusion. In conclusion, a motorizer and adjustable clamp for NDD inspection of pipework is the product concept that was developed using data from customer surveys and benchmarking with existing goods. By using a morphology chart, 5 design concepts were produced during the concept design step. Concept design 4 was chosen based on the client demand and product variability after a round of screening utilizing the partial and rear hinge decising matrix (WDM). In the embodiment design stage, we identify that certain issues and identify components that may be replaced to better our final design. After that, the product technical specification is determined to ensure that the future work can be go through smoothly. Finally, a motorizer and adjustable pipe clamp for NDD expansion of piping with a scope range of 6 inches to 20 inches diameter is completely refined in design and the functionality. Okay, I think that's all from our group 1 from season 6. Thank you everyone.